RL Circuit 2. In the circuit below, EMF is 15 volts, R is 120 ohms, and L is 0.24 Henry. Initially, switch 2 is open and switch 1 is closed until a steady current is reached. Then at time t equals t1, switch 1 is opened and switch 2 is closed. What is the current in the resistor at time t1? What is the voltage drop across that resistor at time t1? What is the current in the resistor at time 1 times 10 to the minus 3 seconds? What is the voltage drop across the resistor at that same time? And how long will it take the current to decrease to half its initial value? What is the current in the resistor at time t1? When S1 was closed for a long time, the circuit reached equilibrium, and we had current flowing like this, and it's a maximum current, and there was no voltage drop across the inductor, so the equilibrium current was just E over R, or 0.125 amps. S1 is now opened, and S2 is closed, creating a circuit with just the inductor and the resistor. Presumably, a make-before-break switching apparatus was used so the current would not just stop. The inductor opposes the change in current, so the initial current will be the same as the equilibrium current, 0.125 amps, and will be going in the same direction as it was earlier, just going through S2 now instead of the open switch S1. What is the voltage drop across the resistor at time t1? Well, that's going to be equal to the current at time t1 times the resistance, so still 15 volts. What is the current in the resistor at time t equals 1 times 10 to the minus 3 seconds? Use the equation for the discharge of an inductor, which we have right down here. When the battery is disconnected, the inductor acts to maintain the current until the stored energy in its magnetic field decreases to 0. It's not a battery. Okay, so here's our equation. We plug in the values, and we get 0.076 amps. What is the voltage drop across the resistor at time equals 1 times 10 to the minus 3 seconds? Well, we found the current at that time, so we just multiply that by the resistance, and we get 9.1 volts. How long will it take the current to decrease to half its initial value? Let's use the equation for the discharge of an inductor, and we want the current to decrease to half of its initial value, which is what it had at time equals t1. So here's our I of the initial value divided by 2. Then we just do some math. We take the ln of both sides, plug in our numbers, and then we get time is equal to 0.0014 second. The key thing was this step right here, and then after that it was just some basic math.